Something happened recently that the world was never meant to find out about. Inside the European Southern Observatory's Communication Center in Garching, Germany, a group of the planet's most senior astronomers walked into a locked conference room under the cover of what institutional protocol labeled a routine data review. No press release accompanied it. No public announcement preceded it. No cameras were invited in. Just closed doors, carefully chosen attendees, and a data set so fundamentally disturbing that the people responsible for understanding the cosmos had collectively decided the rest of humanity was not yet ready to see it. The official label attached to that meeting was deliberately forgettable standard bureaucratic language engineered to attract zero outside attention. But what was actually being discussed inside had nothing routine about it. Scientists were gathered around a table attempting to reconcile observational data that directly contradicted every accepted model of how natural objects behave in space. The object at the center of that crisis was 3I Atlas, an interstellar visitor that had passed through Earth's orbital neighborhood just weeks before, and the data it left behind was not behaving the way data from a natural comet is supposed to behave. The public narrative distributed through official channels was carefully constructed and reassuringly simple. What observers had witnessed, according to that narrative, was an unusual but ultimately natural interstellar comet undergoing thermal stress and gradual fragmentation as it swung around our sun. The language was measured, the explanations were tidy, and the conclusion was predetermined. The actual data, however, told a completely different story, one that the official version had been specifically designed to obscure. According to the speculative telemetry framework designated the pursuit dataset, 3I Atlas was not breaking apart at all. It was deploying. The difference between those two words is not subtle. Breaking apart is chaos, the random, inevitable consequence of structural weakness collapsing under environmental stress. Deploying is intentional. It implies planning, control, and the deliberate release of components according to a predetermined architectural design. Nature breaks, engineering deploys, and the instruments aboard the European JUICE spacecraft, positioned with extraordinary proximity to the object during its closest approach, had captured readings that made the distinction between those two possibilities impossible to casually dismiss. The mass loss rate documented during peak activity reached 1.8 million kilograms per second. Sit with that number for a moment. Nearly 2 million kilograms of material ejected every single second, hour after hour, in a process that continued without interruption across the most environmentally violent phase of the object's solar approach. Standard cometary physics has a clear and well-documented prediction for what happens when a body sheds mass at that rate. It disintegrates. It falls apart. It dissolves into an expanding, chaotic cloud of debris that spreads across millions of kilometers and eventually disperses into nothing. That is what the physics demands. That is what observation of every previous comet has confirmed. 3I Atlas did the opposite. It shed mass in directional structured patterns as though the material being released was not lost, but purposefully redirected following specifications that had been built into the object long before it entered our solar system. The high-resolution imaging system aboard JUICE captured what astronomers would later describe privately as the central forensic evidence of the entire encounter's structured vents arranged with geometric precision across the nucleus surface, releasing material in organized streams that bore no resemblance to the chaotic thermal eruptions expected from a natural comet under solar heating. Inside that locked conference room in Germany, the scientists who understood exactly what those readings meant were making decisions about what the rest of the world would be permitted to know, and those decisions would shape everything that followed. Solar-facing jets are not unknown in cometary science. When sunlight heats the surface of a rotating comet nucleus, volatile ices can sublimate and vent outward through surface weaknesses, creating jets that broadly point toward the sun. Scientists understand this mechanism thoroughly. They have documented it across dozens of comets and incorporated it into standard models of cometary behavior. The existence of jets taken in isolation is not anomalous. What makes a jet anomalous is how it behaves, and the jets captured by JUICE's instrumentation behaved in ways that the standard model has no framework to accommodate. These jets did not activate gradually as 3I Atlas moved closer to the sun and solar irradiance slowly increased. They switched on suddenly with an abruptness that implied triggered mechanisms rather than the passive response to increasing thermal input that characterizes natural cometary activity. The difference in behavior is fundamental. A natural jet intensifies progressively as the energy source driving it grows stronger. A triggered jet activates on command, responding to an internal signal rather than an external energy gradient. The jets documented on 3I Atlas behaved like the latter, not the former. The spectral analysis of the ejected material compounded the problem significantly. The material being released contained concentrations of metallic compounds, nickel and iron, specifically in quantities that far exceeded anything consistent with natural cometary composition. Comets are composed primarily of ice, dust, and organic material. They are not metal-rich bodies. The temperatures required to vaporize nickel and iron are vastly higher than what passive solar heating at 3I Atlas's orbital distance could generate. Something inside the object was producing thermal energy at levels that external solar radiation could not account for, and it was using that energy to accelerate dense metallic material to the velocities that JUICE's instruments recorded. The rotation profile added yet another layer of documented impossibility. During the approach to Earth, the spin rate of the 3I Atlas nucleus changed dramatically, accelerating in a pattern that aerospace engineers would immediately identify as consistent with spin stabilization, a controlled adjustment of rotational dynamics used in spacecraft design to improve structural integrity and trajectory precision. In a natural comet, rapid spin-up produces a predictable and well-understood outcome. Centrifugal stress tears the nucleus apart. The object fragments. Physics enforces that consequence without exception. 3I Atlas instead executed precisely timed mass shedding that maintained structural cohesion throughout the entire spin-up sequence. Shedding calculated amounts of material from calculated locations to achieve a specific rotational state while never approaching fragmentation. The speculative tracking matrix interpreted the sequence as deliberate course correction, the object adjusting its own rotation axis to optimize some internal parameter, perhaps preparing for the gravitational geometry of the Jupiter encounter ahead, perhaps aligning internal systems for the next operational phase of a mission that had been running for far longer than human civilization has existed. The data did not name the purpose explicitly, but the pattern of controlled, sequential, and intentional mass deployment made the intentionality unmistakable to anyone reading the raw instrumental record without an institutional conclusion already in hand. Then came the electromagnetic signature, and that finding changed the interpretive picture entirely. Radio observations from the JUICE magnetometer documented structured electromagnetic pulses in the kilohertz frequency range, and those pulses were synchronized with the solar-facing jet eruptions with a precision that passive natural processes cannot produce. Natural comets interact electromagnetically with the solar wind in ways that planetary scientists understand thoroughly. They create bow shocks, exhibit plasma interactions, and generate diffuse radiation consistent with heating and gas expansion. None of those natural processes produces structured, organized, coherent electromagnetic pulses. Comets do not transmit signals. Every comet ever studied has confirmed this. Until 3I Atlas, the rule held without exception. When genuine scientific anomalies appear, the research community's instinctive response is engagement, not retreat. Scientists argue, publish competing interpretations, claim credit for novel explanations, and drive the conversation forward through the competitive mechanics of academic discourse. This is how the system has functioned for centuries, and its competitive nature makes it nearly impossible to silence significant findings. Permanently individual career ambition works directly against any effort at collective suppression. Researchers want their names on breakthrough papers, not on agreements to stay quiet, which makes what happened in the weeks following the 3I Atlas encounter all the more telling. The scientists who had been publicly discussing artificial origin possibilities went quiet. Researchers who had published early speculation about technological characteristics walked their statements back. Experts who had appeared on broadcast entertaining the anomalous data began issuing corrections, replacing their specific technical observations with carefully worded assurances that nothing genuinely extraordinary had been documented. The community that had erupted in visible excitement at humanity's most direct encounter with an interstellar object suddenly chose collective silence with a speed and uniformity that individual decision-making cannot plausibly explain. That kind of coordinated retreat does not emerge organically from independent researchers arriving at identical conclusions. It requires a shared institutional pressure powerful enough to override the competitive instincts that normally drive scientific discourse forward. And the only motivation capable of producing that level of coordination across competing agencies and institutions is a shared recognition of implications so significant that public acknowledgement was collectively deemed strategically untenable. The data gaps reinforce this interpretation with uncomfortable precision. After the Earth passage concluded, telemetry streams from JUICE began showing intermittent interruptions, periods lasting hours where instrumental readings simply ceased. Spectroscopic data vanished from the record mid-sequence. Electromagnetic observations stopped at points that corresponded with extraordinary accuracy to 3I Atlas's most anomalous behavioral moments. Data feeds cut during peak jet activity. Telemetry silence arrived precisely when electromagnetic pulses surged to maximum recorded intensity. Observation channels went dark at the moments of most dramatic rotational acceleration. The forensic tracking matrix drew the conclusion that the pattern made unavoidable. This was not technical inconvenience. This was deliberate redaction of the observational record. Scientific journals moved quickly to fill the explanatory vacuum. Papers appeared addressing the metallic jet concentrations by reframing them as evidence of an unusually metal-rich origin environment in 3I Atlas's home stellar nursery. The electromagnetic pulses were attributed to exotic magnetospheric interaction effects that had not previously been documented in any comet. The spin stabilization sequence was surrounded with dense mathematical modeling of rotational dynamics in fragmented bodies. Each publication added theoretical complexity, designed not to illuminate the raw data, but to bury it under sufficient academic scaffolding that casual observers would assume experts had satisfactorily resolved the matter. What no paper could explain was the coordination itself. Space agencies and research institutions operate under different national governments, different funding structures, and a long professional history of rivalry and competition. The emergence of identical talking points across these competing entities within a narrow time window is not a coincidence that probability can comfortably absorb. Coordination at that scale requires a shared motivation stronger than institutional competition. And the only motivation that could override that competition was collective recognition that the data showed something for which no publicly acceptable explanation existed. The color shift provided additional evidence that the official framework struggled to address. During its approach, 3I Atlas displayed deep reddish surface coloration consistent with tholins, organic molecules formed on objects exposed to cosmic radiation across billions of years of interstellar drift. This coloration had been cited early in the encounter as supporting evidence for a natural origin. But as the object receded from the Sun, its spectral signature began shifting toward green wavelengths. And the timing of that shift aligned with no natural cometary process that planetary science recognizes. The official explanation for the green spectral shift reached for diatomic carbon emission, a legitimate feature in cometary spectroscopy, where carbon molecules energized by sunlight produce a characteristic green glow. The problem with that explanation was a matter of straightforward timing. Diatomic carbon is destroyed through photodissociation at solar distances. It does not strengthen as an object moves away from its thermal energy source. It weakens and disappears. For the green shift to manifest and intensify as 3I Atlas receded toward cooler, darker space meant that a new chemical process had been activated from within the object itself. Something internal had switched on. Something that was not driven by the sun's energy, but was generating its own. The speculative telemetry framework proposed an interpretation that aligned with the full body of accumulated evidence. The green spectral signature was consistent with ion thruster activation. the characteristic emission of xenon plasma or a similar propulsion medium ejected at high velocities. An ion drive operating within the nucleus would simultaneously account for the electromagnetic pulses, the controlled mass deployment, the geometric precision of the venting structures, and the trajectory management that had kept the object on a course too precise for gravitational drift alone to explain. It would explain everything, because it would mean that 3I Atlas was not a comet at all. It was a spacecraft, an operational vehicle utilizing propulsion technology that human engineering has not yet developed. Executing a mission that had been underway for a span of time that makes the entire history of our civilization look like a brief intermission. The cascade of implications that followed from this conclusion was immediate and profound. If 3I Atlas possessed active propulsion, its trajectory was not determined by gravitational forces alone, but was being deliberately navigated. If the trajectory was being navigated, something was doing the navigating. Some intelligence, some civilization, some technological capability sophisticated enough to build machines that could survive billions of years of interstellar transit while maintaining operational functionality. Machines equipped with sensor arrays capable of analyzing solar systems from interstellar distances, capable of executing precise gravitational maneuvers through the complex orbital architecture of a foreign star system encountered for the first time. This was not a cosmic accident. This was a probe, a deliberate instrument dispatched by a civilization whose technological development predated our sun, possessing engineering capability that makes humanity's most advanced achievements look primitive by any honest measure of comparison. An institutional science confronted with data demonstrating exactly this had decided that humanity was not prepared for that acknowledgement and had moved the information accordingly. The James Webb Space Telescope had been retasked for Jupiter observation windows, not to study cometary fragmentation patterns as stated officially, but according to the forensic tracking matrix, to detect electromagnetic emissions, auroral disturbances, and magnetospheric anomalies that would indicate active propulsion systems operating at gravitational assist velocities. The Deep Space Network and the Square Kilometer Array were being configured for high-sensitivity directional listening, positioned to detect any transmissions from the object as it approached Jupiter's enormous gravity, ready to capture any final data burst before 3I Atlas permanently departed the solar system and vanished back into interstellar space. The question of what such a probe might transmit upon departure occupied the classified discussions that institutional science refused to make public. What would a civilization that sent this kind of instrument consider worth broadcasting back across the interstellar distance to its origin point? The institutional silence on this question suggested that certain decision makers already had working theories about the answer, and that those theories were considered too consequential for open discussion. Jupiter is not simply another planet in the outer solar system. It is the most powerful gravitational engine in the solar neighborhood, a body so massive that it bends the trajectories of everything passing within its reach, rerouting comets, capturing asteroids, and serving as the solar system's most effective catapult for objects seeking escape velocity into interstellar space. When orbital calculations placed 3I Atlas on a trajectory that intersected Jupiter's gravitational sphere of influence, that intersection carried weight far beyond simple orbital mechanics. For natural cometary bodies, Jupiter's tidal forces are definitively destructive at close approach distances. Comet Shoemaker-Levy 9 provided the most dramatic and well-documented illustration of this principle when Jupiter's gravity tore it into a chain of fragments and pulled each piece down to an incandescent end in the planet's upper atmosphere. For any loosely aggregated rubble pile of a body held together by weak self-gravity rather than structural strength, close Jupiter passage represents a physical death sentence. Tidal stress exceeds the cohesive forces holding the material together, and the object ceases to exist as a coherent structure. Planetary science has documented this process repeatedly and understands it completely. If 3I Atlas maintained full structural coherence through a close Jupiter approach, the rubble pile hypothesis would not simply be weakened, it would be physically demolished as a viable explanation. An object that holds itself together against Jupiter's tidal forces is an object with structural integrity designed to survive extreme mechanical stress across conditions that no natural aggregation of ice and dust could endure. The Jupiter encounter would not be merely an observational opportunity. It would be the definitive physical test that separated the natural from the engineered, with a clarity that no amount of theoretical complexity could obscure. Institutional science understood this before the encounter arrived, which is precisely why the machinery of narrative management was already operating at full capacity and showed no sign of reversing course regardless of what the data produced. Scientific journals were pre-positioned with explanatory frameworks. Public communications offices had prepared statements calibrated to absorb anomalous findings within natural-sounding language.